Welcome to qnawire.
Okay, in this one, it says a cell has a standard cell potential of positive. So we want our cell potential, so that's E naught is equal to positive 0.177 volts at 298 Kelvin. And they want to know the value of the equilibrium constant for A is n equals 1, B n equals 2, and C is n equals 3. So they're trying to find K, the equilibrium constant. So the equations that we're going to need to use here are first that delta G naught is equal to negative NF E naught. And then we're going to have to use the fact that K is equal to E to the negative delta G over RT. Okay, so for A, we're n equals 1. So we just plug all the information in. So for n equals 1, delta G naught is going to be equal to negative, so we have 1 mole of electrons here, times Faraday's constant, which is 96,485. Oops, sorry, that's a 5. And that is joules per volt mole times the number of volts, so 0.177 volts. So delta G is equal to negative 17,078 joules. So then I'm going to plug that into my equation for K over here. So I get K is equal to negative, and then it's another negative here. So negative, what did we just have? Sorry, 17078 joules divided by RT. So R is 8.314, and that is joules per mole Kelvin times the temperature of 298 Kelvin. And I get, there's another negative in there, sorry. I get that E is equal to, K in this case is equal to 9.8 times 10 to the 2. All right, for part B, it's the same deal, except in this case n equals 2. So if n equals 2, then delta G naught is equal to negative 2 moles of electrons times our 96,485 joules per mole times volts times our 0.177 volts. And in this case, I get negative 34,000, 156 joules. And then I plug that into my equation for K. So K is going to equal, this was an E to that, E to the negative, and then I have negative 34,156 joules divided by 8.314 joules per mole Kelvin times 298 Kelvin for the temperature, and I get that K is equal to 1 times 10 to the 6th in this case. Finally, in part C, we're doing it all over again one more time, but in this case n equals 3. So I have delta G naught is equal to negative 3 moles of electrons times my 96,485 joules per mole times volts times the 0.177 volts. And in this case, it is equal to 51,000 234 joules. So I come over here and plug that in for my K. K is equal to E to the, sorry, that was a negative in this case again. So E to the negative and then negative 51,234 joules divided by 8.314 joules per mole Kelvin times 298 Kelvin. And this is all on the bottom, so there really should be like square bracket. You're dividing by that whole thing. And you plug that in and you get K is equal to 1 times 10 to the 9th in this case.